So this section was a tiny bit later in Coursera course, but I have taken a bit before and you will see why. Okay. So why study deep learning as a continuation of why we should study AI? Because everything which is true for AI is also true for deep learning, right? Deep learning being a subset. So there are many different reasons of why we should study deep learning, just like as AI. But there are a few important ones. One, okay, this is a really amazing slide where Andrew Ng spent around 10 minutes. Okay, and I think this slide has even more hidden information than what was covered there. Okay, the thing which to notice here, if you see data volume. So, what is deep learning? Deep learning is nothing but a neural network. A neural network which you build, if you build it deep, it is quite complex. Deeper neural network you build, more complex problems it can solve. Okay. So, as you can see, deeper neural network you build, more complex problem you can solve. That is the y-axis. Okay. And more data you pass to the neural network to learn, as long as it is relevant data and as long as it is there is something to be learned, it will learn from it. So if we simply scale the amount of data, okay, we can actually get an improvement in performance from a certain neural network complexity. If we increase its complexity, now suddenly it can actually learn even more. It can actually feed even consume even more data to derive intelligence. So as you can see, there is a theoretical upper limit on based on size of the neural network, how deep and how complex you have made it to be. Okay, so after a certain point it doesn't learn anymore, not simply because it doesn't it has plateaued. Doesn't mean you can't learn any more from the data. It simply means by using the learning algorithm, however bad it is, that learning algorithm's limitation we have hit. Okay, but in really, as you can, if you just see what is here, the complexity of the network. So the simple analogy is, imagine neural network is nothing but what we have in our brain. Our brain is nothing but a very complex neural network, right? So complexity of the brain, if you simply increase, more complicated things it can do. Okay. And how does it learn to do those? By learning from the data, right? So as you can see, the power of neural network can improve simply if we increase the data volume and hardware improves. The problem which we can solve with help of deep learning is not dependent on human understanding here. You see, any field improves as our understanding of the field improves. So generally, the innovation which is holding back is human bottleneck. We, not enough skilled people are available, not enough creative people are available, not in there is generally either money or it is lack of people who know that skill, right? Here, as you can see, even if we have those, even if you have lack of money and even if you have lack of human, the thing which you can do can be achieved simply with more hardware power or more volume of relevant data. Okay, it is also, if we understand deep learning even a bit better, there are better innovations happen. It will of course improve the deep learning models capability, of course it will. But even if we are as stagnant as we are now, as long as the money we spend acquiring data and the hardware power required to to run that problem, as long as I can still make profit, I can invest that much money, right? So you see, some of the problems, they are actually impossible to solve because the technology is not here. We are waiting for technology and enough progress to happen. Here, we could we can simply reach there by feeding it more data, or having a more hardware, giving a more powerful hardware, or running it on an even more distributed way. So this graph is amazing that way. Okay. So another way to look at this is look at the data complexity. One way to look at neural networks is also as it is a pattern learning machine. Neural networks are nothing but pattern learning machine. If the data is complex, the patterns are in that data are even more complex, and we need a larger, more complicated network to simulate that pattern, right? So that's what it is. Here, whenever the performance is plateaued, it doesn't mean that we can't learn anymore. It means we have hit the limits of how good our architecture is, how efficient our algorithms are, how good our hyperparameters are. So this is the worst case scenario for a certain example. So if we take a data volume, a specific data volume here, okay, on this y-axis line, if you take just one point here, okay, this is the worst case performance, where we are simply using brute force computational power and brute force amount of data required. But to be really honest, to get that performance, we can do a lot of architectural innovation and any learning rate innovation, hyperparameter innovation. There are many things we can do. So we can get the same performance in much less data and computational power. So if this is the theoretical worst case scenario, but with intelligent work, we can get very, very far. And there are other things like we already have pre-trained neural networks available. What do I mean by that? Okay, imagine neural networks are nothing but brains. Okay, raw brains. A learned brain is nothing but a trained neural network. Okay, so because if we have some existing pre-trained neural network, what does it mean? We have a structure which has already been trained to learn, it has learned something already. To something which has already learned quite a bit, we can add just a tiny bit of knowledge, and it can do what we need it to do, right? So you see, simply with of architectural innovation and data, better utilization of data and better error calculation, whatever it may be, we can reach here its performance. Not here, but as you can imagine, we get a lot of improvement, and with help of pre-trained model, we can get even more. So this is the worst case scenario. A lot more improvement with this thing, pre-trained model, a lot more improvement. So as you can see, this is how we are going. Better our knowledge is, better things we will be able to do. And you see, by learning the worst case way, which is like the basic new type of neural network, that is the worst case performance. That's our starting point. Okay, and then we will improve performance one by one after that. So we won't learn the improvements before we have learned the basic, and the basic points are quite limited, and that's why I've structured it this way. The real basics of the neural networks, just get any worst case performing neural network ready, they are limited. So by mastering them, we can become conversant quite fast. So that's why I think this slide is amazing, if you just look at it from this perspective. So that's why I love it. So this is independent. It by simply scaling hardware and data volume, we can actually improve our deep learning performance. And here, two things. Internet. We love internet. Why do we love YouTube? Because we do time pass on it. And if we need to do some enjoyment on YouTube, someone needs to create content. And there is so much data being uploaded on YouTube. Every second, there is more than a petabyte of data. 1000 terabytes, 1001 TB hard disk would be needed. That much amount of content is being uploaded every second on YouTube. Every second, a similar content is on Instagram and LinkedIn and this thing and blogs. So you see, any work which humans have done, there is a lot of intelligence in it. It is said, right? A picture is worth more than 1,000 words, or audio might have a lot of things like, what is being said, what is implied emotion. So many tiers of knowledge. So because of internet, and internet has now become a mode of communication, right? Internet is a virtual communication, and anything which is happening virtually, that is a data we can learn from. Constantly there is something more to be learned, something more to be learned, more to be learned. So actually, right now, the amount of data we have, right, we have not even scratched its surface. There were some stats, I think even we haven't done analyzed 1% of possible data, and for that we have not even done 1% of what all we could do. So there is a lot more. You only need to think, and the only constraint now is the reward to effort ratio worth it? Okay, so a creative person can do a lot more things because of the data volume we have with internet, right? Now hardware has the same thing. I'm adding a bit of point here is AI's hardware is improving drastically. Nvidia is building specialized hardware, and for next 10 years, the AI hardwares will become tremendously amazing because, as you can see, scale drives deep learning progress. That's why many complex problems which are important to be solved can be solved by brute force. So if we can solve them by brute force, the company which provides hardware can also make a lot of money. So you can see there is companies whose aim has become supplying the hardware and collecting the data, and there is so much existing data on internet. So many things have come together for deep learning. Okay, uh, as a consequence of all that, okay, this is what has happened. We have incremental improvements in all fields. Generally, all fields have linear progress, but progress becomes exponential if there are some factors which multiply the speed of progress. And what is multiplier? Because it is independent of the understanding, we can brute force our way out there. And once we have a brute force solution, it is actually quite easy to optimize it, right? Any brute force solution, even if let's say Google solves it once and it makes the model open source, we have the answer ready. We can refine on it and improve on it, and we have an answer. So this there is so many components. Like we said, there are so many reasons because of which deep learning is at a inflection point. Okay, and these inflection points are strategic inflection points. I mean, add some bit of efforts from your side and a pre-existing growth in deep learning field. When you have good skills and you're riding a pre-existing growing field, it's quite useful, and that's the amazing thing. So, second most important reason. So it's independent. Deep learning can grow independently simply by scaling on data and hardware. And second thing is it has become economically rewarding. Okay, consider the audience base of following. Google search. Billion plus people use Google search every day, right? And now we have ChatGPT, Microsoft and Google fighting for dominance of simple text search with help of deep learning. Okay, we have YouTube, we have Netflix, we have Unreal Engine 5. If you can just check just what Unreal Engine can do. Unreal Engine 5, it can build such an amazing video game worlds that they can be used instead of movie sets. Okay, so it's amazing. The movies of futures, they will require much less money because once you build the special effect thing in video game, it can be used. It can be reused, and there is a lot of time saved. So this thing is another race which companies are fighting. Netflix and YouTube, and there are other companies which are doing. There are companies which are fighting the gaming fight, PS, PlayStation, Xbox, and many other things, and they are going to merge with entertainment and movies. And already, video gaming's revenue is more, at least 10 times more than movies, music, actual sports combined. So, this is a huge field, and it is going to merge with entertainment, and it is going to be indistinguishable from it. So, these are the places where companies are fighting so hard. Why? Because the thing which is enabled by deep learning is so valuable. So, by considering audience base, if you just multiply it with the service you need to feel like charging, let's say whatever problem you're solving, if you can guarantee there are 1 million audience who has that same problem, $10 per month multiplied by 1 million, you have $10 million earning revenue potential, right? It is very economically rewarding. Effort to value is quite a bit. So you can spend that a much amount of money simply on more hardware, more data. And if you can do it smarter, you don't even require that much data and that much hardware. You can do it much in much less things. Of course, you need expertise for that. But as you can see, the economical viability, the economical rewarding, and these hardware things, these are the things because of which deep learning, especially, is quite booming. Okay. And it is so versatile, it is so general purpose that any data it can learn patterns from. Okay, example of that, you can check this Python's packages. Okay, so Python is a programming library in which many people have built libraries for whatever domain they are from. Any place which has data, we can add intelligence to it with help of deep learning. So whether it is communication, art, or facts, or file sharing, or databases, every single thing, there is things for astronomy here. There is things for protein, artificial life, bioinformatics, chemistry. We have geostationary data, hydraulics, hydrology. There is mathematics, medical science, physics, crypto, geology, genealogy, whatever, anything you can think of, AI can be used there. Deep learning can be used there. Okay, as long as you have data for it. And this versatility is an amazing thing. It's powerful, it's versatile, it is economically rewarding now, and it is independent of just human thing. You can just brute force your way out of it. So you see, it's so amazing that these are the things which are combining together to lead such a flux of interest in deep learning. Okay, and that's the precise reason I have decided to spend so much time mastering the fundamentals, because they're that important. And this lecture went through all of them really nicely. Okay, so and if you think by just solving the problem once you have reached the end, think again. People think once you have a AI solution, that's the end of it. That's a very simplistic way of thinking. If we can solve something, next time we need a better solution. Okay, if we solve something by brute force, what is stopping other companies from copying the same thing? Nothing, right? So we always have to improve our solution. So we have not yet reached the limit, any limit of what deep neural network can actually theoretically do. For example, right now, whatever vision state of art solutions we have, they are still less accurate than what a vision processing of a mosquito or even a housefly can do. So we have to go very far in human understanding. Let's say imaginary data, we can still go to 1%. We can go even more complex data and even better improvement. So things will always be improving, and we'll always need people who improve those. So that's why learn deep learning and its economical value is huge. Okay. So these are all the reasons. It's versatile, it is very powerful, it is accessible to everyone. So a few individuals with their intelligence and their knowledge of deep learning can do a much more powerful thing before only people with huge money could do. Okay, this is where intelligence is actually rewarding. This is where deep learning enables meritocracy. If you are smart, you don't need as much data or compute. You can actually achieve much more amazing results. And let's see. I'm planning to do something amazing, when the assignments come. Let's see how successful I am. So this was the, why study deep learning. And after this whole thing is made, we can actually start studying deep learning and their process. And Andrew Ng goes into more details about it later.